Welcome back to the Explainer. For our big 50th milestone, we're taking a ruthless look at the literal building block of civilization, water. Good old H₂O. Now, if you've been following our audits of fundamental materials, you know the drill. We judge without mercy, and we absolutely do not give out nostalgia points. We've tackled everything from granite's timeless foundation to iron's sheer workhorse dominance. But today we're auditing the universal solvent itself. It's so ordinary we completely take it for granted, right? Yet it freezes to preserve our food, it boils to generate our power, and it flows to transport practically all our global goods.
71%. That is how much of our planet's surface is covered by this stuff. It is by far the most abundant, yet arguably the most precious material we have. I mean, look in the mirror, and you're basically looking at water, since it makes up a massive 60% of our own bodies. We're literally built out of this molecule. Without it, there's no life, there's no civilization, and, well, there's definitely no material for us to analyze.
But, and this is a big but, as we face the harsh reality of global freshwater scarcity today in 2026, we've got a really critical question to answer. Is this universal solvent truly an undisputed S-tier material, or do humanity's massive flaws in mismanagement just completely drag its ranking down? Sure, it can sustain entire ecosystems, but it can also wipe out cities through floods and droughts. To get to the bottom of this, we're going to audit water across 4 key areas: shaping human history, its extraordinary properties, our modern mismanagement, and finally, the ultimate tier verdict.
Okay, let's jump right into Section 1, shaping human history. We can't really understand a material without tracing how it's built our world.
Think about this. From enabling the very first ancient Mesopotamian irrigation around 8000 BCE, all the way to becoming a highly strategic climate resource today in the 21st century, water has actively powered every single major human leap. Think about the Nile civilizations. They thrived purely off the river's annual flooding. Then the Romans, right? They engineered these massive, sprawling aqueducts just to move fresh water into their crowded cities. Fast forward a bit to the 19th century, and water literally drove the Industrial Revolution by boiling into steam. And by the 20th century, modern sanitation and massive dams completely transformed global living standards. Every chapter of human history is quite literally written in water.
Moving on to Section 2, extraordinary properties and uses. Let's look under the hood at the mechanical specs that make water completely unmatched. Honestly, this single molecule is just incredibly overpowered. Operating effortlessly in solid, liquid, and gas phases naturally on Earth, it safely dissolves more substances than any other liquid out there, which totally earns it that universal solvent title. On top of that, it has an incredibly high specific heat capacity. Basically, that means it acts as the ultimate thermal regulator. It can absorb a massive amount of heat before changing temperature, which is what stabilizes our entire global climate. And its cohesion and adhesion properties, that allows for capillary action. That's exactly how giant trees pull water from their roots, all the way up to their highest leaves, totally defying gravity.
But water's absolute best cheat code is the density anomaly. You know, for almost every other substance in the entire universe, the solid phase is denser than the liquid phase. But not water. Actually, scratch that. Water expands when it freezes. It's a crazy quirk that makes ice float, and that literally keeps ecosystems alive during the winter by insulating lakes and oceans from the top down rather than just freezing solid from the bottom up. Fast forward to our modern applications in 2026, and the numbers are wild. A staggering 70% of global freshwater goes straight into agricultural irrigation. That completely dwarfs our domestic hygiene and drinking use, which is sitting at just 15%. Alongside another 15% for industry and energy. So the takeaway here is that while we mostly think of water as something we drink, it is overwhelmingly something we use to grow our food.
But it's not just farms, it's fueling tomorrow's tech too. This incredibly ancient molecule is currently serving as an essential cooling agent for the massive data centers that power our digital lives. It's the key ingredient in green hydrogen production, where we're literally splitting it to create pure fuel. And with advanced tech like atmospheric water harvesting, we are pulling this resource straight out of thin air to supply regions that desperately need it.
Which brings us to Section 3, humanity's greatest mismanagement. Water is life, but we need to talk about the brutal truth of how we're actually treating it. We're caught in a terrifying paradox right now. We have this globally abundant, non-toxic material with a fully renewable cycle, but it's plagued by severe, localized scarcity. Because of exactly where and how water falls, many regions are just completely parched. And when we try to engineer our way out of that with things like modern desalination plants, we get hit with massive energy costs just to purify it and make it usable.
Basically, human mismanagement has turned our most vital resource into our absolute greatest challenge. We're talking about severely over-extracted groundwater. We're literally draining ancient aquifers way faster than the rain can refill them. We see widespread industrial, agricultural, and plastic pollution everywhere. And what's super fascinating but also kind of scary is the virtual water trade. This is the hidden water embedded in the everyday goods we export and import. When a dry, drought-prone country exports water-intensive crops, they are essentially exporting billions of gallons of their most precious resource, and often without even realizing the true cost.
All right, Section 4, the final tier verdict. It's time to put H₂O through the rigorous material ranking system. No mercy, just the data.
Now, its scalability does take a bit of a hit, down to an 8, mostly because of those incredibly high energy costs for clean access and desalination today. But man, everywhere else, it completely sweeps the board. It pulls perfect 10s in historical impact, workability, versatility, and lasting relevance. It flows, it freezes, it boils, and it dissolves effortlessly. It has enabled literally every major technological leap we've ever had. Its mechanical properties sit at a massive 9.5 because its natural phase changes are practically unmatched anywhere in nature. So, averaging all those scores together for our March 2026 audit, water achieves a monumental 9.6 out of 10.
That lands water firmly, and I mean firmly, in the S tier. It proves it is the undisputed champion and the bedrock foundation upon which every other material, and life itself, exists. Without it, nothing else on our ranking board even matters. It is for sure the ultimate material.
So, I want to leave you with this final thought, straight from our analysis today. In 2026, water remains both our greatest resource and our most pressing challenge. If water is truly the ultimate S-tier material, are we actually doing enough to protect the very molecule that makes our future possible? Take a hard look at how we treat this 9.6 champion and ask yourself what part you play in its story. See you in the next explainer.